Hey, welcome back. Today we're doing operations with radical equations like adding and subtracting. Ooh, very fun. So we're going back to this simplifying radicals stuff because you need to be a pro at that. And you're looking for perfect squares that go into 52. A perfect square that goes into 52 is 4. It's 4 times 13. And then you square root your 4, which is 2. 13 doesn't have any perfect squares left in it. Remember, we always ignore 1 because it's in everything and it won't get us anywhere. 200. Anything that ends in 100 is nice because 100 is a perfect square. So 200 is 100 times 2. The square root of 100 is 10. 10 times 10. So we have 10 root 2. No perfect squares left in 2. 4 root 54. Okay. I know that 9 goes into 54. It's 9 times 6. Square root of 9 is 3. Remember, we multiplied by the 4 that was already out there. So we have 4 times 3 root 6. 4 times 3 is 12. 12 root 6. 6 does not have any perfect squares left. 125x squared. Anything that ends in 25, 50, or 75, 25 goes into all of those. Think of quarters. So think of the number of quarters in $1.25. There's 5 quarters, so it's 25 times 5. The exponents, remember we need even exponents for it to be perfect, which we have. Square root of 25 is 5. Square root of x squared, we divide the exponent by 2. We just get x to the first. 5x root 5. All right, let's try adding some of these. Now the thing with adding these radicals is you have to have like radicals. Just like if you had 2x plus 5y, you can't combine those and make them just 7x, right? But if I had 2x plus 5y plus 6x, we could combine the x's together. So it would give us 8x plus 5y. And that would be simplified all the way. You can't combine unlike terms when you're adding or subtracting. Same thing goes with the radical. You can only add them or subtract them if they are the exact same number in the radical. So let me scooch over here and let's see what we've got. Root 2 plus 3 root 2. Think of if it said x plus 3x. Oh, that's an invisible 1 in front of the x. 1x plus 3x would be 4x. It is the same thing here. It's like 1 root 2 plus 3 root 2. The 1 plus 3 is 4. Now, you're going to be tempted to add the radicals together. You don't add them. It stays root 2. The roots only change when you multiply or divide them. Kind of like with the exponents. When we were adding like x squared plus x squared, we didn't change the exponent. You only change it if you multiply or divide. These are both root 5s. So we could just combine them. Negative 3 root 5 minus 4. So we're just doing negative 3 minus 4, which is negative 7. And we got the root 5 behind it. These are both root 10s. We have 1 root 10 minus 5 root 10. 1 minus 5 is negative 4. And then we got the root 10. That's not bad, right? So when they're the same, it's pretty easy. But sometimes they're not the same, and we have to break down the perfect squares, and then sometimes they'll be the same. So we got adventures coming your way.